Hello, my name is Ruben Chavez, and I am a graduate student at the University of Illinois at Urbana-Champaign, and I will be the narrator of this video series. This work was supported by the IFAN's Food Microbiology Committee. The implementation of sampling systems has helped the food industry improve food safety and reduce risk associated with contamination. However, in many bulk products, expected contamination with pathogens and mycotoxin is low, usually less than 1%, making it difficult to reliably detect contamination when it does occur. In addition, in the industry, safe and unsafe are not simply binary conditions that can be identified, and absolute safety is impossible. Therefore, food safety strategies must seek to maximize the reduction of risk to generate food that is safe for consumers. Therefore, new tools are needed to maximize the probability of detecting target hazards and minimize the potential for outbreaks that affect the safety of consumers and generate food waste. The United States Food and Drug Administration, the United States Department of Agriculture, and the International Commission on Microbiological Specification for Foods have established microbiological criteria and sampling plans for detecting hazards in food that improve food safety and hazard detection. However, even with these criteria, contamination with pathogenic bacteria and mycotoxins are often non-homogeneous and occur at low concentrations. In order to reliably detect hazards, a large number of sampling points or larger size of samples is required. However, large production quantities and supply chain logistics in the industry create a challenge for sampling larger quantities and determining the right sample size that increase the probability of detection efficiently. This requires extensive knowledge of statistical analysis and quality reports of the production lot, which further increase the challenges for efficient sampling. For produce and corn, a new web app offers a solution to these problems by providing a platform to virtually simulate the sampling power of the intended sampling strategy and compare the effectiveness of various sampling approaches. This app can be used to evaluate different sampling plans and optimize sampling methods to improve the probability of detection of hazards efficiently, hence improving our ability to confidently identify hazards that affect the food safety and security. This app is specifically designed to optimize hazard detection in two types of bulk products: in produce in a field and in corn in trucks, hoppers, and barges. This model works by first simulating the target hazard, including the number of contamination points, the contamination area, and the distribution of hazards in the affected zone. The model will simulate various sampling strategies based on the number of probes and method of sample collection, followed by simulation of sampling processing, subsampling, and detection assays. Ultimately, the simulation of a decision on whether to accept or reject the lot will occur. In a couple of minutes, this whole process is iterated thousands of times to calculate the probability of detection of hazards according to our intended sampling strategy. Through this method, the app will offer a metric based on quantitative risk modeling to measure how reliable the analyzed sampling plan is at detecting mycotoxins or pathogens. In summary, the purpose of this app is to simulate sampling strategies that are intended to be used in a produce field or a bulk container and evaluate how powerful those plans are at detecting targeted hazards. By entering information describing the sampling plan into the app, the model can simulate the proposed scenario and evaluate the plan's effectiveness for accurately accepting or rejecting the produce or corn lot. By changing the inputs in the app, the user can compare various sampling scenarios and determine what kind of sampling plan works best for their specific scenario. This ready-to-use bulk sampling simulation app will offer a complementary tool to the required protocols established by USDA, FDA, and ICMSF, as well as other food safety programs implemented in the food industry such as hazard analysis and critical control points, good manufacture practices, and sanitation standards operating procedures to implement sampling modeling for improvement of sampling strategies in produce and corn. In the videos that follow, I'll demonstrate how users can use the app to compare and analyze different sampling scenarios without the need to replicate them in real life.